Okay, so in that last video we did tables, we did graphs, ways that could turn out to be accurate if you have like these nice, clean, neat answers, but there are situations where like making a table would be really inconvenient and it would take too long, and making a graph might not be all that accurate. Like a couple of the ones that we looked at on the homework had like these weird x-intercepts, and there are ways that are easier, and we call these the algebraic methods, and it's basically working the solutions out by hand. I think the two methods that we're going to do here you should have seen before in Algebra 1, so hopefully they're familiar, and hopefully this is kind of just a review. So the substitution method, we're going to walk through the steps. I'll write them down. I think it's kind of nice to have them written right in front of you so you can just access them. So the first step is to solve one equation for one of the variables. Okay, so solve one equation, because you're always given two. Meaning that what you want to see in front of you is like x equals whatever or y equals whatever. So you want to get either the x or the y totally by itself. Doesn't matter which one. Pretty much just whichever one's easier to get by itself. And we'll talk about that. Next step is to sub this expression. So substitute this expression. So if you get like x equals some expression, you want to sub that expression into the other equation. Then solve. Okay, so you'll get it to a point where you only have one variable, and when you only have one variable, then you can solve for it. Okay, then step 3. Sub this value to solve for the other variable. Okay, sub this value in to solve for the other variable. All right, so let's go through. So part A, in example 4, step 1, solve one equation for one variable. So what you want to do is you want to look for a variable that's alone, meaning no coefficients, other than 1, of course, because it always has 1. So we're going to take that second one. What we're going to do is we're going to subtract the 2x from both sides so that we can get the y by itself. So this will cancel. And then my second equation will be y equals 7 minus 2x. So that's step 1. We solved the second equation for one of the variables, meaning we got the y by itself. Then it says sub this expression into the other equation. So the logic behind substitution is, all right, if y is the same as 7 minus 2x, couldn't I write this y as 7 minus 2x? And the answer is yes, of course. That's what we're going to do. So we're going to write this first equation, but we're going to replace the y with this expression. So 5x minus 3, and instead of a y, I'm going to sub in this expression, because this equation right here tells me that they're interchangeable. Okay, so I'm kind of right in the middle of step 2 here. Solve, meaning I got to simplify this all up and solve for x. So 5x doesn't change. I'm going to distribute this negative 3, so 21, and then negative 3 times negative 2x is positive 6x. Equals 23. On the same side, I'm just going to add these like terms together, and I get 11x minus 21 equals 23. Next step would be to add the 21 to both sides. So I end up with 11x equals 44, and finally I'll divide both sides by 11. So I get 4. That's my first variable, first value. Then I'm going to sub it back into this equation, because this equation is already solved for y. So next I have y equals 7 minus 2, but instead of x, I'm going to replace it with a 4. Okay, so this is 7 minus 8, and 7 minus 8 is negative 1. So your answer should be written in an ordered pair, x first, then y. So remember what this means is if I were to graph these equations, this is the point where they would intersect each other. Just one point, which means it's a consistent, independent system from that last video. Okay, next, this one. The x is easiest to get by itself, so we're going to add 7y to both sides. So this cancels. So I can write this as x equals 11 plus 7y. Next step of the substitution process is to take this expression right here and sub it in for this x. So 5, instead of x, I write 11 plus 7y from my substitution. and then finish off the second equation. Okay, still part of the second step, we're going to solve for this first variable. So start by distributing the 5 to both of these pieces. Then finish with the 4y equals negative 23. On the left-hand side, I'm going to combine my like terms. So combine 35y and 4y, and I get 39y. Okay, a couple more steps to get y by itself. I can subtract this 55 from both sides. So I end up with 39y equals, and this is going to give me a negative 78. Okay, last, finally, divide both sides by 39. So this, you might not know this immediately, but this actually ends up being a negative 2. 78 divided by 39 is 2, and of course there's a negative there. So that's why I'm going to sub y in right here and get x. So x equals 11 plus 7 times negative 2. So that is 11 minus 14, which is a negative 3. So remember, when you write your ordered pair, we call it ordered for a reason. The x should always be first, then the y. So that would be your answer. So this is another consistent, independent system. All right, so that's substitution. I'm hoping that was familiar. We're going to do the elimination method next, and we're, again, going to start by writing down the steps. So steps, we are going to first multiply one or both equations by a constant. So you'll see once we actually look at an example what you mean, or what we mean, to result in equations with opposite terms. Okay, multiply one or both equations by a constant to result in equations with opposite terms. Example, we want maybe one of the equations to have a 4x, and we want the other equation to have a negative 4x. That's what we mean by opposite terms. So that's our goal. We want to pick either x's or y's to eliminate them. Next, add the equations to eliminate one variable. So maybe we eliminate the x's. Once we eliminate the x's, then we can solve for the y's. So then solve. Solve the equation that you get. So at the end of step 2, you'll have one of the variables. Then you can sub that in to solve for the other. Okay, sub this in to solve for the other. All right, so we're going to go through. We're going to look at a couple of examples of the elimination method. And again, I'm hoping that this looks familiar too. So, elimination method. So if we take a look, we've got positive x, those are not opposite. Positive 2y, positive 1y, also not opposite. The easiest way is to make the x's eliminate. All we have to do is multiply one of the equations by a negative 1. Does not matter which one. I just happened to pick the bottom. You could pick the top and you'd end up with the same answer. So let's do a rewrite. So no changes made to the first one. In the first one I have a positive x. Then I'm going to multiply everything through, and make sure you do multiply everything through. So negative x, negative y, negative 6. So everything has to be multiplied by a negative 1. Same balance on both sides. So the x's will cancel, which is exactly what we were trying to do. And then we have positive 2y minus y. That leaves me with a y equals 10 minus 6 is 4. So that was actually pretty straightforward. We got the y by itself. That's our answer. And then the last step is to sub this into one of my equations and solve for the other one. So let's go into the first one. So x plus 2y, so I'm going to replace the y with a 4 because I just solved for it, equals 10. Okay, so now 2 times 4 is 8, so I can subtract 8 from both sides to get the x by itself. So remember, your answer should always be listed as an ordered pair, x first, then y, so this is the point where my lines intersect each other. Okay? And second elimination example here, we have a 6x and a 4x. Those aren't opposite. We have a negative 5y and another negative 5y. So in order to make them opposite, all I have to do is multiply one by a negative. So I'll choose the top one this time. So multiply through by a negative 1. Notice we could have made the x's eliminate too. We could have made them positive and negative 12x. So like I could have multiplied this by a positive 2 and this by a negative 3 to get opposite 12x's. You've got lots of options. I'm just sticking with the easier one. So multiply the whole top equation by a negative 1, which means all three of those signs will change. And then just line the second one up right underneath it because we didn't make any changes to it. Okay, so elimination, I lose the y's, and then add everything else up. So negative 6x, positive 4x, positive 8, negative 12. So last step would be to divide by that negative 2 to get x by itself. So careful here, negative divided by a negative leaves me with a positive 2. And then I'm going to take that 2 and I can plug it into either one of my equations. Does not matter which one, you'd get the same answer either way. So might as well just stick with the top one. So 6 times x, which I now know is 2, minus 5y equals negative 8. 6 times 2 is 12, so I can subtract that from both sides. I'm left with a negative 5y. Make sure you keep that negative in front of it. Equals negative 20. And then last step, divide both sides by the negative 5. So I end up with 4. So I actually ended up with the exact same intersection point as the previous one, which is kind of a coincidence. So remember to write it as an ordered pair. Okay, so last thing that we're going to do here is do a multiple choice example. So we're still going to pretty much do it the same way. If we look at these ones here, we could either get the x's or the y's to eliminate. Doesn't really matter. Let's pick x's. So here's a 2x. This is a 6x. We can get them to be opposite 6x's. So if I multiply this top one by a negative 3, I'll have a negative 6x, which will eliminate with this positive 6x. So I'm just going to line it up right underneath. So if I multiply through by a negative 3, I get negative 6x, I get negative 9y, and I get negative 15. Okay, so hopefully you noticed as I was lining this up, everything's going to cancel out. Okay, so what I end up with is 0 equals 0. So this part's super important for when you're working on your homework and when you take the mastery check. 0 equals 0 is a true statement. Like 0 does actually equal 0. So if you end up with a true statement, what that means is that there are an infinite number of solutions. That means that the lines are actually the exact same line, which means that one lies right on top of the other and you have an infinite number of solutions because they're the same line. If, okay, this is like a secondary piece of information. If you end up with a false statement, you know, something like 2 equals 0 or something like that. So if you get a false statement, something like 2 equals 0, then there is no solution. Okay, so you either get a real answer like these, or you get a true statement at the end with no variables, and that's infinite solutions, or you get a false statement at the end with no variables, and that's no solution. Okay, so there's just a chart right here to kind of sum up all of the systems that you guys have seen so far. We did table and graphing on the previous video. We just did substitution. And then we've got kind of a couple different ways that we could do elimination. And this is what we were focusing on, was this one down here. These ones are only if the equation is perfectly lined up from the start. So this is probably what you'll be using. So hopefully this will be helpful. We've got multiple different methods here. And I think, yep, that's the end. All right.